Let us try and understand Angular SHM now. Now, Angular SHM, now this is a disk. This is a disk which is tied with a string and is rotated this way, right? Now, if it is rotated this way, that itself means that the angular displacement theta is in this direction. Now, we know that whenever it is rotated this way, there is some restoring torque generated in the string which will bring it back. Now, if it is rotated anti-clockwise, so there would be twist generated in the string, as a result of which that would generate a restoring torque in clockwise direction. So both are opposite direction. So that's why first argument, that is tau, torque, is directly proportional to minus theta. Why minus theta? Directly proportional. Why? First of all, since more the angular displacement, more the restoring torque generated. You can just visualize it. Suppose if a disk is tied with string and we are just keeping on twisting it, as we leave, we will find that it will return back, or rather it would return back with great angular velocity. All right. So tau is directly proportional to theta. And why negative? Because we already found out that angular displacement, if we are taking it in anti-clockwise direction, then torque would be in clockwise direction. Okay. So now when proportionality goes, there's a constant which comes into picture, and we also know force, mechanical force is equal to mass into acceleration. That is in case of linear state. Now we already in physics have proved that mass is equal to moment of inertia because it cannot move by itself. All right. So I, that we have proved in physics already. So m is I, and linear acceleration is angular acceleration. So tau is equal to I alpha. This formula we have seen earlier. So instead of tau, we replace it by I alpha is equal to minus c theta. All right. So coming back over here, so we got this. Now I take it that side, so it becomes I alpha plus c theta is equal to 0. All right. Now alpha, we know it is d2 theta by dt square plus c theta is equal to 0. Now as I've just shown here, in case if you have forgotten, which I had derived earlier in my earlier videos, as d by dt of dx by dt is equal to d2x by dt square. Similarly, here also d by dt of d theta by dt, we know d theta by dt is omega here. Now here dx by dt was v. So this was angular velocity omega. So d by dt of omega gives you d2 theta over dt square. All right. So it's just analogic. It becomes easy for you whenever you are going into rotational motion if you compare it with linear motion, because linear motion we have been seeing earlier. So when we get exposed to rotational motion, just apply the same theory of linear motion and its analogy to rotational motion. All right. Okay. So as we did here. Fine. So I d2 theta over dt square plus c theta is equal to 0. So this we know is angular acceleration. So we can replace it by alpha. I alpha is equal to, I take it this side, minus c theta. All right. So alpha is equal to minus c theta over I. All right. Now see, earlier we had seen f is equal to minus kx. Now f is ma. So ma is equal to minus kx. So a is equal to minus kx over m. All right. Similarly, here also alpha is equal to minus c theta over I. Instead of m, we have got here I. Instead of k, we have got here c, proportionality constant. Instead of linear displacement over here, we have angular displacement over here. So it's analogic. All right. So see how easy it becomes if you compare it with linear velocity. So whenever I would request you guys that whenever you are doing angular stuff, correlate it with linear stuff, so it becomes easy for you to understand and to carry forward. Okay, let's proceed ahead. So Here we have already proved alpha is equal to minus c theta upon I, where c is constant, theta is angular displacement, I is moment of inertia, which again is constant. So alpha is directly proportional to minus theta. Now minus theta means alpha and theta are in opposite direction, and at the same time alpha is directly proportional to theta also, because more the angular displacement, more would be the torque generated. Alright, so two conditions required for SHM satisfied. So satisfy requirements for oscillatory motion to be SHM. C and I being constant, as K and M we saw in our spring reaction, force and spring, as K and M. Alpha being directly, so alpha being directly proportional to theta, first condition, and being opposite in direction of angular displacement. So this we saw is opposite to the angular displacement, and it is also directly proportional to theta. So SHM done. So now we can call it as angular SHM. Alright.